Hey everybody. Before we get going into electrochemical cells in the next video, I want to go back to N35 and the very last example I was showing you, where calcium ions were forced to reduce by reacting them with elemental potassium, because potassium's potential to oxidize was greater than the reluctance of calcium plus 2 ions to reduce. So it kind of forced it to do it. Now I was using it as a demonstration of that principle, that a very spontaneous process can cause a pretty non-spontaneous thing to happen. But I wasn't really giving you the full truth about what the actual chemistry of the situation was. And maybe you started thinking about this, and if you did, it's great if you did. Sorry, forgot the charge on the potassium there. And so that was kind of the final product, and we said yes, this reaction would happen spontaneously. However, the reality of the situation is slightly different than that. And you can see the title of what I've got up there on the iPad. It says Redox reactions when there is a choice. What do you mean by a choice? The reality of the situation is that the calcium ions at the beginning of the reaction aren't just like floating around on their own. Okay, there's other things around. And so what you actually have, and so I'm actually going to write a little arrow, and I'm going to say what you actually have would probably be, you can still have elemental potassium. So it can still be a chunk of potassium and you throw it into, but what you're throwing it into is probably not just calcium ions. It is a solution of calcium ions, which would mean it would be a dissolved calcium ionic compound, right? A soluble ionic compound. So it could be NO3, it could be Cl, it could be any other ion that calcium's soluble with. So the reality of the situation, because it's a really common one, calcium chloride is really common, is that you probably have a solution of calcium chloride. And then we did your typical chemistry 11 single displacement, and you ended up with 2KCl aqueous. Now that still has the same E cell. The cell potential is exactly the same as what you had up above. But this is a little bit more of the reality of the situation. Now, the other reality of the situation is that, sure, the potassium is oxidizing. We can see that. It's going from K to K plus 1. But the reality of the situation is that if potassium is going to oxidize, something needs to reduce. We are making the assumption in the original example I gave you in 35, we're making the assumption that the calcium ions are going to reduce, that it's the only possible thing that can reduce. The general rule of thumb, though, is that the reaction that occurs will be the most spontaneous reaction that occurs, which means if there are choices of what the reducing agent or oxidizing agent can react with, then it will react with the thing that is the most spontaneous with it. So if we make the assumption that the potassium is going to, if the potassium is going to do this, we made the assumption that calcium plus 2 was going to do the reduction. But there are choices. It's not just the calcium that could potentially reduce, because there's other things around in the water. Well, what about the Cl minus, or whatever ion that the calcium is with? What if that ion could reduce? Now, that's where, like, having an understanding of the table and is this chemical a possible oxidizing or reducing agent, that actually becomes very important, being able to establish that. So if I had calcium chloride aqueous solution reacting with potassium, or potentially reacting with potassium. You ask yourself, well, the calcium ions, they are a possibility. They could reduce into calcium. The chloride ions, the Cl- ions, could they potentially reduce if the potassium oxidizes? So you'd look for Cl- on the left-hand side of the table, and what you would find is that they can't. So Cl- is not an option. But there is another option, and it's slightly hidden, but it's there. And the second option is water. Because you have an aqueous solution of calcium, you have water as being a possibility of reducing. Can water reduce? Well, if you're a little bit uncertain as to whether it can reduce or not, you go to the table and you look for water on the left-hand side. And water reduction has kind of two lines that you're looking at. And if you listen to my narrated answer key, you would have seen me explaining this. Let me get rid of all of this. It's all right. So there's actually two places where water is on the left-hand side, so therefore potentially reducing. Now, which of those two lines? They're actually forming the exact same products, but you're going to choose this bottom line because what the top one actually means, and it's kind of critical that you understand this, that right there, that plus 2 hydroxides and then in brackets 10 to the negative 7, that actually means that we're that is a neutral water situation. Well, that means you're producing neutral water. Well, if we're going to be reducing water, we're going to be producing hydroxide. We're not going to be having a neutral solution. So really what these two lines are, that top one that's shaded is actually not for the reduction of water. It's actually only for the oxidation of hydrogen into water molecules if that hydrogen happens to be in a neutral watery environment. That's what it actually means. So that line is not actually the reduction of water, which means if it's not actually the reduction of water, then we're not even going to be looking at that line. We're looking at this one right here. There's water reducing. So if we go back to that original question, we're talking about these are our potential. We've got potassium oxidizing into +1, and then we've got two choices. Choice number 1 was the calcium, but in reality choice number 2 is the water reducing. So you've got these two things. Well, what's the potassium going to react with? The potassium will react with whatever chemical gives it the largest potential difference, so the largest E cell. Well, we already figured out that the calcium and the potassium were plus 0.06, so it was spontaneous, but it was barely spontaneous. This one, if water happened to, oh boy, if water happened to be the reactant, then you'd be talking about negative 0.83, and you'd be talking about positive 2.93. So as a matter of fact, the E cell, if we're talking about water, would have been positive 2.10, which is way more spontaneous than if calcium was to reduce. So if we go back to this situation where there's a choice and water reducing is one of our choices, which all of a sudden you have to start thinking, well, water reduction is always a choice if you happen to have something dissolved in water and you're trying to oxidize or reduce it. Water always becomes a choice. And for many things, actually, water will be the more likely choice because it will tend to react a little bit more spontaneously. So, as a matter of fact, the calcium, I mean, I know I used it as an example. I didn't give you any choice. But as an actual practical example, that if I were to take potassium and throw it into a solution of calcium chloride, the calcium chloride won't react at all. The actual spontaneous reaction that will occur will actually be two potassiums thrown into some liquid water will produce 2 K pluses aqueous. H2 gas will bubble out of there, and then 2 hydroxides. Now you might write the 2 potassiums and the 2 hydroxides together as a formula and write them as 2 potassium hydroxides. Whatever, it doesn't really matter. But that's actually the reaction that would spontaneously occur. I know I used this reaction up here to demonstrate a point. The reality of the situation would be, and of course, I mean, my goal for you guys is to understand chemistry from a practical and a point of view where you can actually apply it to a practical situation. That if you take potassium and throw it into calcium chloride solution, it will react with water rather than the calcium chloride. Okay? So if there's choices, you have to go through the choices, and the most spontaneous reaction is going to be the one that actually occurs. Okay, there you go.